Hello, this is Miss Nivens. Today we're going to start Unit 10, Lesson 1. Students will factor polynomials using the greatest common factor. Do you remember this from last year where we had to find the GCF of 40a squared b cubed c and 48a b squared c cubed? So we had to write the prime factors of each, and that's when we used our factor trees and we wrote it as a list. And then from our list, we had to find the ones they had in common. And we were looking for the greatest common factor. Well, they have 2, 2, and 2 in common, so 3 sets of 2. So 2 times 2 times 2 is 8. So we know that 8 can go into both 80 and 48. We also look at the A's, and they have one set of A's in common, 2 sets of B's, and one set of C's. So when we write that in exponential form, 2 times 2 times 2 is 8. A, B squared, C is our greatest common factor. Factoring is a process of writing a number or algebraic expression as a product of factors. Basically, we're going to be undoing the distributive property. We'll be doing the distribution process in reverse. So in other words, when we begin with 6x cubed, 8x squared, y cubed, and then are told to factor, how do we accomplish this? Well, let's try it. 6x cubed plus 8x squared, y cubed. I try to think, what's the biggest number that can go into both 6 and 8? And I know I can divide them both by 2. And I look at what else do they have in common? Well, they have x's in common. And the biggest number that can go into x cubed and x squared is x squared. They do not have y's in common. So I figured out that my GCF is 2x squared. Now, as a shortcut, I'm going to divide both of my terms by 2x squared. So I'm just simplifying, and that's what we did in this last unit. So what is 6x cubed divided by 2x squared? Well, 6 divided by 2 is 3. X cubed divided by x squared is x. Remember to subtract our exponents. Do the same thing with the next term. 8 divided by 2 is 4. X squared divided by x squared is 1, so it cancels out, and then we have y cubed left over. And we are finished. Now, if I were to distribute 2x squared to both of these terms, my answer would be 6x cubed plus 8x squared y cubed. This is what we did in Unit 9, where we distributed, and in Unit 10, we are undoing the distributive property. Let's try some more. Again, we have 9y squared plus 45y. Look to see what they have in common. What can go into both 9 and 45? The biggest number that can go into 9 and 45. 3 does, but 9 is bigger. So we can divide them both by 9. Then again, look at y squared and y. What can go into both y squared and y? Well, y can. Now I'm going to divide both of these by 9y to get my second part of my expression. 9y squared divided by 9y is plain old y, because 9's cancel out to make 1. 45y divided by 9y, 45 divided by 9 is 5, and the y's cancel out to make 1. And then, if I distribute the 9y, I would get my original answer. Let's try another one. 14x cubed plus 63x squared minus 7. What can go into both 14, 63, and 7? Well, it's pretty easy to see. It's got to be 7. So I can divide them all by 7. Now look at x cubed, x squared, and x. And I always look for the smallest variable. In this case, x is the smallest, so I can divide them all by x. So divide each of these by x to get our second part of our expression. 7x. 14 divided by 7 is 2. X squared divided by x is x cubed divided by x is x squared. Plus 63 divided by 7 is 9. X squared divided by x is x. And then negative 7x divided by 7x is not 0, it is 1. So you must represent your answer with a 1. And then again, if you look to see if you want to check if you distribute it, you would get your original answer. Let's try a couple that are a little bit harder. We've got negative 5g cubed minus 15g squared. And the big GCF would be a negative 5. So we can divide them both by negative 5. If we look at g cubed and g squared, well, g squared is smaller. And set up our second expression. Divide both of these by negative 5g squared. Here, the negative 5's cancel out to make 1. You got g cubed divided by g squared is plain old g. Negative 15 divided by negative 5 is positive 3. G squareds cancel out to make 1, and that is my my factored expression. This one's a big one. Don't be scared. We can do it. We've got 14, 21, and 42. What can go into both 14, 21, and 42? It would be 7. A to the 6th, A to the 5th, A. Again, I always look for the smallest one, and it is A. B cubed, B, and B squared. Again, I look for the smallest one, and it's B. C, C, and C cubed, and it would be C. So they have 7ABC as the common factor. All right? Divide all of these by 7ABC. 14 divided by 7 is 2. A to the 6th divided by A is A to the 5th. B cubed divided by B is B squared. C divided by C cancels out to make 1, plus 21 divided by 7 is 3. A to the 5th divided by A is A to the 4th. The B's cancel out and the C's cancel out. Negative 42 divided by 7 is negative 6. A's cancel out to make 1. B squared divided by B is B. And C cubed divided by C is C squared. And you have factored that trinomial. As a review, to factor a polynomial is the opposite of distributing. The first step in factoring should always be to look for a GCF. In factoring, we write down the GCF followed by parentheses. In the parentheses, we place the remainder of each term after dividing out the GCF. I hope you took good notes, because now we need to go to our Google form online and complete. You guys have a nice night.